So far, we learned how to manually discover a number of very dangerous vulnerabilities. We've seen how they work and how to exploit them. In today's video, I'd like to show you a tool that will allow you to automatically discover vulnerabilities in web applications. It'll allow you to discover the vulnerabilities that we learned, plus much more. The reason why I didn't teach you this at the start, because I wanted you to learn how to do it manually, and I also wanted you to know how these vulnerabilities occur, so to understand the reason behind them. Also, these are just tools, so this program is just a tool. It can make mistakes and it can show false positives. It can also miss vulnerabilities in some cases. Therefore, I wanted you to know how to do this stuff manually, so if the program doesn't work or if the program misses something, then you'll be able to find it. The best way to use these programs is as a backup or as just a tool to help you with your penetration testing. So using the tool is very simple. I'm going to go on my applications and then I'm going to type in Zap. And it's asking me if I want to save the current session when I search for something. So I'm going to say no. And this is the main view of the tool. So on the left here, you'll see the websites that you're targeting. On the right, you can attack and set the website URL. And in here, you'll see the results for your attacking or for your scan. If we go here on the cog on the left, it will allow you to modify the options for the program. So you can modify certain aspects of it, the way the fuzzer works, the way the spider works, the way the scan works. I'm going to leave everything the same. Another thing that you can modify is the policies used in the scan. So it's something similar to the scans that we were using with Nmap, the intense scan and all that. So I'm going to press on the plus. I'm going to press on the active scan. And if you press on this on the left here, and I'm going to press on the default policy. Now you can create your own policies by using the add button. I'm going to press on the default one and I'm going to go on modify to show you the aspects that you can modify. So right here, you can modify the name, the threshold, and the strength for the global policy. Clicking on each of these categories will allow you to modify the specific scans that will be performed. For example, in the injection tab here, we can see all the injection scans that the program is going to try. For example, we can see SQL injections here. You can see cross-site scripting here. And pressing on the threshold right here, we can set this to default, low, medium, or high. Setting it to the default will just default to the value selected here, which is medium right now. Or you can have, for example, if SQL injection is what you're looking for, what you're looking for is access for the database, then you can set this to high so that it'll try everything and it'll try to find it in even difficult places. So I'm going to close all of this. I'm leaving everything the same. And I'm going to start my attack against the Matilda script. So we have it in 10.20.14.204 running in the Metasploitable machine. And if we go on Matilda right here, that's the URL. So literally, I'm just going to copy this and paste it here. And then I'm going to attack. Now the tool is first going to try to find all the URLs, and then it's going to try and attack these URLs based on the scan policy that we used. I'm going to pause the video and resume it once the scan is over. So the scan is over now, and you can see on the left here we have our website. Clicking on it will show you some results of the spider when it was looking for the files. The very interesting part is the alerts here. Right here you can see all the vulnerabilities that have been discovered. On the left here you can see that we have 7 red flags, so these are the high priority alerts. We have 3 orange flags and 5 yellow flags and 0 blue. So these are organized in the order of their severity. Clicking on any of these categories will expand it and show the threats that have been found related to that threat. For example, clicking on the path traversal, you'll see all the URLs that can be exploited to read files from the server. Clicking on any of these, you'll see the HTTP request that was sent in order to discover this. You'll see the response that why the tool thinks that this is vulnerable, and we can see that in the response, the tool was able to get the contents of etc password. Right here, you can see the URL that the tool used to exploit this vulnerability. And in here, you can see a description of what the current vulnerability is and how it has been exploited. In here, you can see the risk of it. So this is very high. You can see the confidence. So how confident the tool about the existence of this vulnerability. You can see that it's been injected into a page and the attack is trying to get etc password. So let's try and right click on this and open it in browser. And as you can see now, it exploited it for us and it showed us the output for this vulnerability, and we can read the contents of etc password. And you can see that the exploit is being exploited in this URL right here. Let's have a look on another example. For example, a cross-site scripting. And again, the tool also checks for post and get parameters. So sometimes when the injection is sent into text boxes or even sent without text boxes, if it's sent in a post parameter, you won't see it in the URL. So it actually checks for post and get. And you can see here it found a vulnerability in a post request in the register page. And it also found one in a get page. Again, right click and open in browser. Will execute it for us and we can see the code has been executed. Again, we can have the URL of the execution right here if we wanted to use it with Beef or any other tools. And we can see it in here as well, the URL that's being used to exploit this vulnerability. Let's just have one more example of an SQL injection. Again, click on it. It will show you why it believes that there is an SQL injection here. It will show you the URL and it will show you the attack that it used and 1 equals 1. And it's in the parameter password. And if you remember, we actually did exploit this parameter. Opening this in the browser will show us that the injection is working and it's using a username and a password called Zap. So the tool is very simple, very powerful and very useful. You can play around with it. You can play around with the proxy and with the options and see how you can enhance the results and achieve even better results. So far in the website hacking section, we learned how to gather information about a target website, how to discover a number of vulnerabilities in the web application, and how to exploit these vulnerabilities to gain access. I actually cover more vulnerabilities and more advanced techniques in my website hacking course. This is just an introductory course to most hacking fields without diving too deep in any. Check out the bonus lecture, the last lecture of the course, for more information. But in all of the previous lectures, I knew what kind of vulnerability I'm going to use. And that's because I'm teaching you these specific vulnerabilities. So people usually ask me at the end of this section, so how do I know which vulnerability to use? Or how do I know which vulnerability to try? And the answer is try all of them. I only try a specific vulnerability per lecture because I've already done my tests and I already know what to try and what to show you, so I don't waste your time. But if you're pen testing a specific website, you're gonna have to try every single vulnerability that you learned. So the basic methodology would be to first of all gather as much information as possible about the target as usual, discover all of the subdomains, all of the hidden directories, all of the web applications installed on it, And then for every domain or subdomain, we're going to click on every single link. We basically want to use every single feature of the website and get an understanding of how this website works. So when we break it, we know we actually broke this and it might be vulnerable. Then for every link, for every page that we browsed, we're going to try all of the vulnerabilities that we learned by testing the parameters in this page. And what I mean by the parameters is the input boxes that you see on the page, and you want to test the data that is sent over the URL after the equal sign. So let me show you a quick example of what I mean. Let's assume that you're trying to discover vulnerabilities in google.com. You're going to come to google.com. We're going to discover every single subdomain on google.com. So you're going to have to go to accounts.google.com, adsense.google.com, and so on. And for every page that we get in here, we're going to click on every single link. So for example, we have the How Search Works link in here. We're going to open it in a new tab and we're going to come to it. You'll notice that in this page, again, we have more links. So we're going to have to click on every single link of these. And then for every page that we get, we're going to first of all try to use it to see what the page does, to get an idea of the features that this page has. And then we're going to try to discover the vulnerabilities that we learned by manipulating the inputs. So we're going to first play with the inputs in here in the URL. So you can see this URL, we have fg is equal to 1. So after the fg equals 1, we can actually try to inject stuff. We can test for SQL injections, we can test for XSS, and so on. And we can also go ahead and test this input box for XSS. Google was actually vulnerable to an XSS, and they paid a huge bounty, I can't remember what it was, to the person that found it. So don't think that these vulnerabilities don't exist in big websites like Google. So the main things we'll be testing is the input boxes and the things that we see after the equal sign. And you'll basically have to test literally every single vulnerability that you learned. Like I said, there is no way to know by simply looking at a page that it's going to be vulnerable to an SQL injection or to an XSS, for example. Now, in other cases, you might have websites like Z-Security here, for example, where if you click on a link, you'll actually not see the equal sign in the URL. So you won't see the data that is being sent to the server in the URL. This does not mean that this web application, this page, does not send data to the server-side application, but it's just more hidden and harder to see the data that is being sent. You can actually see the data that is being sent and manipulated using a proxy. So Burp Suite is a really popular pen testing framework that actually comes with its own proxy where you could intercept requests sent from this current page to the web server, so you can actually get more parameters and be able to test these parameters for the vulnerabilities that we learned. And you'll also be able to use it to bypass certain types of security measures. Now, I actually cover Burp Suite and I cover a lot of other more advanced web application vulnerabilities and techniques, like I said, in the website hacking course. I don't cover them here because this is an introductory course to ethical hacking in general, and the goal of this course is to introduce you to most ethical hacking fields without diving too deep in any. So if you want to learn more about web application pen testing, about Burp Suite, about OWASP top 10 vulnerabilities, then check out the bonus lecture. It includes that course, and to see all of the other courses that are applicable to you. Throughout the course, we learned a number of methods to discover bugs and vulnerabilities in different types of software and infrastructure. Usually, at the end of the pen test, you will need to inform the client with all of the vulnerabilities that you found or with all of the findings. This is done using a pen test report. So basically what we mean by a pen test report, it's just a document that includes everything that you found through your engagement, so that the client or the admin can go ahead and fix all of the vulnerabilities and the weaknesses that you found. These reports are also read by executives a lot of the time, therefore you would need to account for that. So a good report should be easy enough, but it's also easy to understand. Now, if you're working as a pen tester, then the company that you're working for will probably have their own template and their own standards that you have to follow when writing a report. And in many cases, you won't even be doing that. You'll simply be forwarding your findings to another member in your own team, and they will be filling the blanks properly in the report. Therefore, you probably will not need to write one from scratch, and in many cases, you won't even write the actual report that the client sees. With that being said, I still want to show you how this is done, just to give you an idea of what a pen test report looks like. Now, first of all, before I show you the sample that I have, I'm going to include this repository, which basically contains a large number of pen test reports. So you could actually look through these for inspiration and just to see the different styles that different companies follow when making a pen test report. So you can click on any of these and you'll find the report, and you can actually go through it to learn how this specific company write their reports, and maybe you find something that you like that you would start including in your own reports. So I'm going to include this in the resources of the lecture, so you could come back to it for inspiration. But what I really want to do is walk you through a sample report that we use here in Z-Security, just to give you an idea of the main sections that most reports have. I will also include this in the resources, so feel free to modify it and use it, or take some elements of it if you want to. So you'll notice from the repository in here, each company has its own style of writing reports, but in general, there is always a few main sections that you will find in every report. So starting with the first page right here, we have the covering page. So again, you can style this as you want. You usually have the company logo, you have the title, and then you'll have the date of the report and the version. This is very important. And then we have the company, our company information. So this report is written by us. This is our company information. And then you have in the for field, you have the company that you're writing this report for. So you'd have the company name. You'll have a specific ID for this company. This is the ID that you identify this company within your own records. Again, this is probably not something you'll be doing yourself. You'll be given this ID by your own company. And then we have contact information for both companies. So you can see in this company, we have Pentester 1 and Pentester 2 with their email addresses. This could be obviously a bigger list with all of the team that is doing the pen test. And similar to the company that you're doing the pen test for, again, you have their names, their position in the company, and their contact information. Now again, keep in mind, you don't always have to style the first page like this, but more or less, usually in the first page, you'll have the title, the date, the version, and the contact information. This is how we do it, but again, you can do it the way you want, and you can draw inspiration from the resource that I'm going to include here. Next, we usually have the table of contents. Again, as you can see, simple stuff usually you would have in any kind of document. This will help you navigate throughout this whole document, and like I said, in here, we can see the main sections of any pen test report. So it's very important to have an executive summary. This is a summary of the whole engagement that is designed for less technical people. So it's supposed to give them an idea of your findings without diving too deep in the technical details. Then we have an engagement summary where we detail the scope. So this is what you tested, which parts of their system that you tested, the risk ratings that you used, and an overview of everything that you found. So again, so far we're not diving deep. This is just a summary of the whole engagement. You'll get a better idea of all of this as I go through the report. And then in the technical details section, this is where you dive really deep in everything that you found. So we basically have a section for every finding. So as you can see, this is just a sample. So I only made 3 findings. We have an SQL injection, a cross-site request forgery, a CSRF, and an information disclosure. So as you can see in the first section, we basically just had a summary of everything that we found, whereas in the technical details, we're basically breaking down every single finding. And we're going to talk about how we found it in details, how to replicate it. You're going to include screenshots if you can, so that the technical team can understand exactly the severity of this vulnerability and how to fix it. You'll notice other companies will include appendix at the end. They will include recommendations where they will tell you exactly how to fix vulnerabilities. Like I said, it really depends on the company. Every single company have their own style and every single company have their own format. So what I'm showing you right here is just a sample of how we do it. You can draw inspiration from the resources, and in many cases, you'll just have to follow the template that your company has because they don't want you to do it your own way. So let's go to the next page, and you'll see in this page we have the legal information. And that's why I actually said you'll probably not do this yourself. You'll never need to do this yourself because you'll have parts of the report like this you'll never have to modify, and they'll actually be written by the legal team in your company. So they'll account for anything that could go out of control to make sure that you will not be sued if anything goes wrong. It'll contain stuff like disclaimers, GDPR, privacy, legal stuff, and all of that stuff that we don't really know very well as pen testers and legal people usually write. And then we have the changelog of the document. So every time a change is made to the document, you can see we have the date, we have the version, and we have a comment. Why did we do this change, or what's so significant about this change? So this was the initial report when we made it on January 1st. And then on the 10th of January, we made the second version where we are done with the recon stage. Again, this is just samples, but just to give you an idea that keeping a change log of all of the changes that this document goes through is very, very important. Not all of the companies do it, but again, that's just our own choice to add it in our report. I keep saying this just to give you an idea that there is no set rules to making these kind of documents. You can add or remove anything you want, but the main parts would be the legal part, the executive summary, and then the technical part. These will be the main parts of the report. So now we have the executive summary, and you could read through this. This is not supposed to be long, so in my opinion, it needs to be a page, maximum 2 pages if you really have to. And it basically just says, we were instructed to test X system. It'll explain how this document is organized, where the first section is less detailed, just to give you an idea of the risk. And then the second one is detailed for the technical people to understand these risks and fix them. And then we're given the risk rating, so we're assuming this is at high risk based on the vulnerabilities we found. It'll detail the methodology that we followed. And then we have some charts in here. Remember, this part is being read by the executives. These are people that are not very technical most of the time, and they also don't have a lot of time. So we're including graphs in here to show them the amount of vulnerabilities we found. So we can see we have 5 vulnerabilities that are high. We have 10 that are medium and 8 that are low. So this will give them a really good understanding of the threats that they face. And then we're going to go into the summary. Again, this will still be read by the less technical people. So first of all, we're detailing the scope to make sure that we tell them what we tested, even though they already told us what to test, just so that in case in the future, if something was discovered outside of our scope and they come back to us, we can say, well, this was outside of the scope. We did not test this. Next, we're including the risk ratings. So you'll have this in every document. You won't need to modify it. We're basically just saying how we would classify a certain vulnerability as low, medium, high, or critical. And we're saying, in our opinion, how you should handle the low, medium, high, and critical vulnerabilities. You can see for the critical, we're saying you need to fix immediately, whereas for the low, you need to fix in the next update cycle. Again, this is just our own opinion. Next, we have the findings overview. So we're still in section 1. This is still for the executives. We don't need to dive too deep. So we're just given the vulnerability ID. And you can see for the first vulnerability, it's critical. It's an SQL injection. And in many cases, in many reports, they'll actually stop at saying it's just an SQL injection. We like to actually show the impact in this section because, like I said, these guys are not technical. So if they read SQL injection, they might not know what an SQL injection is. What they care about is the impact of this vulnerability. Again, they don't have a lot of time, so you need to be straight to the point. So what we're doing is we're saying it's an SQL injection that could lead to unauthorized database access. So now they know with this vulnerability, a hacker can access their database. This is probably pretty bad. Another vulnerability that we found is medium, and it's a CSRF. Again, many reports will stop here. Doesn't really explain anything to non-technical people. So we're saying clients can be forced to submit certain non-critical requests. That's why it's a medium. It's not non-critical requests, but they can be forced to submit stuff. And then we have one low vulnerability where the PHP version is disclosed. So this is not really very critical because it's not an actual vulnerability that can be exploited to gain access or expose user data, but this information could be useful for hackers to chain with other attacks or discover vulnerabilities for this specific PHP version. And that's why it's a low, that's why it doesn't need to be taken care of very urgently like the critical ones, as we mentioned above in here. And feel free to read the text in here. You'll see a lot of it is basically just to clear our backs and make sure that they understand everything that is in the report. And that would be the end of the summary. And now we're into the technical details. So in this section, we're basically having, like I said, a subsection for every single finding that we have. And we're diving really deep into the details of this finding. So you can see this is the SQL injection that we mentioned earlier in the summary. But this time we're actually giving them the URL that is vulnerable. We're giving them the vulnerable parameter. We're giving them references to understand what SQL injection is in case they don't understand it. We're giving them the exact request and the exact response that we got, which made us determine that this particular page is vulnerable to an SQL injection. Then we're giving them the impact here in details, not just saying that they can access the database. So we're saying they can access the database, they can retrieve data, we got access to the users table. So you're going to dive in details, and you should even include screenshots in here if you think they'll be useful. In the mitigation section, we're just giving them a quick recommendation. Like I said, some companies give detailed recommendations. This really depends on the engagement as well. So in this example, we're basically just saying use prepare statements with parameterized queries, and we're giving them a reference to learn how to do that or to understand how it works. And that's pretty much it. So you're going to repeat that for every single vulnerability you found. I'm leaving the rest empty, as this is just a sample, but you get the idea. So you're going to have a subsection for every finding that you have, explaining everything in details so they understand the vulnerability and then they can go ahead and fix it. At the end, many companies would have an appendix and they might have a bigger recommendation section. Like I said, this is our style of writing reports, but each company has their own style. If you like this, maybe spend some time going through the sample reports that we have in this repository. Obviously, I'll include both links for my sample and for the other samples in the resources so you can go through them yourself and get an idea of what pen test reports look like. But like I said, in many cases, you'll simply be filling a sample similar to what we have in here, so you'll never be asked to come up with one from scratch. Hello everyone. Today, instead of talking about hacking and breaking into systems as we usually do, we're gonna talk about security and specifically how to secure websites, web applications, mobile applications, and so on. Obviously, hacks and breaches have a huge negative impact on companies, from the loss of customer trust to financial losses, leaked user data, legal issues, and the list goes on. Now, if you go and do a quick Google search on how to secure your website or application, you're gonna get a lot of garbage. I was actually so disappointed at the clickbaity articles that actually did not explain or give any useful information. Most of them suggested that you use backups, use strong passwords, and make sure you use HTTPS, but backups don't secure your website, they simply help you recover. Also, using HTTPS encrypts the communication, but it doesn't really secure the website. The only one useful tip was use strong passwords, but most hackers are not going to sit down and try to guess the password like you see in Hollywood movies. They're going to rely on vulnerabilities and weaknesses within your application, and they will exploit them to gain access to it regardless of what password you use, even if you have a very, very complex password, even if you're using HTTPS, and even if you have backups. A lot of this is actually irrelevant. Also, it doesn't really matter where you have the application hosted, whether you're using AWS or any other cloud provider, and it doesn't matter how you're deploying this application. If you're using Kubernetes or if you're using Docker, it doesn't really matter. It's actually very, very simple. If you have a vulnerable web application, then hackers are going to use these vulnerabilities or weaknesses to gain access to this application. So anyway, enough ranting, let's talk about how to actually secure websites and applications. First of all, before we start talking about it, it is very important to understand that achieving 100% security is impossible. All which we are trying to do is to improve the security of our applications and make sure that they are as secure as possible. With that being said, the following 4 approaches will help you improve the security of your applications regardless of what kind of applications they are and regardless where they're installed. Like I said, doesn't matter if you install them on Amazon or anywhere else, on AWS or anything else, and it doesn't matter how you're deploying it, if you're using Docker and so on. So the first thing that you should do is make sure that you are writing secure code. This way, your application is built from the ground up to be secure and to not introduce any bugs or vulnerabilities that can be exploited by hackers to gain access. Now, this would be great if you can do it, but the problem is it's easier said than done because the developers need to be educated and taught the methods that hackers use to exploit systems and gain access. And even if you do that, a lot of the time developers rely on third-party libraries and the whole application might be written by someone else. Therefore, you simply cannot write secure code because you're not actually the writer or the developer of this application. Which brings me to the second point, review the code. This is actually really good, even if you wrote the application yourself and even if you made sure that you write secure code, it's a really good idea to get that code reviewed by other developers or another team, just in case the developers that wrote the application missed something or overlooked something, then it will be caught at the review stage. Also, if you were using code written by other developers or third-party libraries, then again, a code review will fix this problem because you can review everything. And again, this is really, really good because you're actually reviewing every single line and making sure that nothing is vulnerable or will allow hackers to exploit your application and gain access. The main disadvantage here is that if you have a large code base, this could be very time consuming and it could also be very expensive. The third approach, which is very essential in my opinion, is getting a pen test done. In a pen test, you basically hire a team of ethical hackers to try and hack your application. These ethical hackers will approach your application the same way that black hat hackers do. They're going to try to gather as much information as possible, discover all the weaknesses and vulnerabilities, and see if they can exploit them to gain access. At the end, when they're done, they're going to give you a detailed report of everything they found so you can pass it to your developers and patch any vulnerabilities they discover. The main advantage of this method is you could test attack surfaces that you cannot test with other methods, such as your servers that are running your web application and the weakest link, which is the employees. So these hackers, the ethical hackers, can even use social engineering and chain it with other simpler attacks or simpler vulnerabilities that they might find on your system to see if they can use them to gain access. The disadvantages here is that it could be a little bit expensive and it's not future proof. What I mean is, if you get your application tested today by really good ethical hackers and then make sure you patch every single vulnerability they find, this only means that your web application is secure today. It doesn't guarantee that it will remain secure for the next month or next year, because every single change you make, every feature you push, or every even display bug you fix might introduce other bugs or security weaknesses that can be then used to hack into your application. Not only that, but again, if you're updating third-party software or plugins, again, all of that could introduce vulnerabilities, and a pen test will not be able to catch that because you're only doing the pen test today, and these future changes are not going to be tested. The fourth approach, which can actually address this issue, is having a bug bounty program. A bug bounty program is basically an invitation to all ethical hackers around the world to test your application and submit their findings, and you would only pay for valid bugs or valid reports. The main advantages here, as you have guessed probably by now, is that you're getting your application tested by a large number of hackers, so the chances of them finding vulnerabilities is higher. And it's actually future proof because as long as you have that bug bounty listing, live, these hackers will always continue to test your application, and you motivate them with bounties. So these could be anything from a t-shirt to actually monetary awards to make sure that they're actually going to continue testing your application. So even if you're pushing new changes, new features, or updating stuff, it doesn't really matter, because hackers will continue to test your application, hoping to find bugs and get bounties for their findings. That's why large companies like Facebook and Google use these bug bounty programs. Even though they follow all of the other approaches, like I said, they still use this to make sure that their systems are always as secure as possible and as free of bugs as possible. The disadvantages here is, first of all, it's hard to guarantee that all attack surfaces are covered. And second is, a lot of companies don't have the reach that Google and Facebook have, so they can't really advertise their bug bounties as well as the big companies do. They can't get a lot of ethical hackers to test their website. It is challenging for them to make these bug bounty programs and validate the submitted reports. But this is addressed by the bug bounty platforms that we have these days, such as bugbounty.com and the other platforms. Bug-Bounty is actually a sister company of Z Security, so my opinion might be a little bit biased, but I'm pretty sure that our prices are the most competitive and we offer the same service. So anyway, I'm including everything there. You have the choice. You can check out whatever you want. And I'm sorry if I actually confused you with the 4 approaches that I just mentioned, but in my opinion, ideally, you would want to follow all of these 4 approaches if you can. This could be pretty expensive. That's why a lot of companies don't do that, and they would compromise and only go with 3 and 4. So they'll only do a pen test and have a bug bounty program. And then other companies sometimes compromise even more and pick one of the 2, either do a bug bounty program or do a pen test. In my opinion, a pen test is not a replacement for a bug bounty program, and vice versa. I would recommend you do the 2 of them because, like I said, each one of them has its advantages and disadvantages. But if you really can't do both, then at least do one of them as the bare minimum. As a website owner or an app owner, you are responsible for the user data that the users are trusting you with. And therefore, you need to do at least the bare minimum on trying to make sure that their data is handled safely and is secure.